Here we have AP Calculus AB problem. Okay, let's go to the question. At a musical concert, the audience stands inside a semicircular area of radius 50 yards. The stage is also a semicircular type of radius 10 yards. If the density of the audience at R yards from the center of the stage is given by F of R people per square yard, which of the following expressions gives the number of people at the concert? Okay, now let's consider an important information we have over here. So that is the density of the audience at R yards from the center of the stage is given by F of R. Let's consider the center of the stage. This is this dot over here, center of the stage. And when I consider a distance of R yards from the center of the stage, for example, instead of R, let me take some value 11 yards. So let me consider a point which is at a distance of 11 yards from the center of the stage. So we know that this distance is 10 yards. When I take a point at a distance of 11 yards from the center of the stage, it will be somewhere else over here. Okay, so this is a point which is at a distance of 11 yards from the center of the stage. Now, if I want to find the number of people at this point per square yard, that is in 1 square yard, so that is given by the function f of r. Okay, for example, if I give r is equal to 11 into the function, that f of 11 will give the number of people per square yard at a distance of 11 yards from the center of the stage. So now our aim is we have to get the area of this region. So then we have to multiply the area of the region by the number of people per square yard. So when I do so, I'll be getting the number of people at the concert in this shaded region. For that, what I'm going to do is I'm going to consider a small strip around this semicircle of radius 10 yards. So now let me unfold this small strip as a rectangle. Then I'll be getting a rectangle over here. Let me draw it. Okay, so what is the length of this small strip? Actually, the small strip is in the shape of semicircle. So when the radius is r, then the length of this small strip is given by just pi r. So which is the circumference of the semicircle. So then when I unfold this small strip, it will become a rectangle. Then the circumference of this semicircle will become the length of the rectangle. And so here the thickness of the strip is the width of the rectangle over here, and the starting value of this thickness is going to be 10 because we have people from 10 yards. So 10, the starting value over here is 10. 10, if I take the ending value as 10.01, so then the width of the rectangle is 0.01. So it's not like that I have to take 10.01. If I want, I can take 10.02 or 0.3, any value. So accordingly, I'll be getting the width of the rectangle. So clearly, the width of the rectangle is a finite change in the radius from 10 yards. So whenever there is a finite change in the variable, it can be written as delta and that variable. So here the width of the rectangle is a finite change in the radius, so we can write as delta r. So delta r is a finite change in r. When delta r, usually in calculus delta r approaches 0, it will become dr. So delta r represents a finite change in radius. So dr is a very small change in the radius. So instead of delta r, if I write a dr over here, then the width of the rectangle will be a very small value close to 0, something like 0.00001, something like this. So it's very close to 0 when I write a dr instead of delta r. Okay, now to get the area of this small strip around this small semicircle of radius 10 yards, we have to multiply. Actually, we have unfolded this small strip as rectangle as I've shown out here. Now to get the area of this rectangle, I have to multiply the length, that is pi r, by the width of the rectangle, that is dr. Okay, so this is the area of the small strip over here. And also please remember the thickness of the small strip is a very small value because we have taken dr. So how many such strip can be taken in this shaded region? So when dr is very close to 0, we'll be taking infinite number of small strips can be taken. So when the width of the rectangle is very close to 0, so infinite number of rectangles can be infinite number of strips, and each strip can be unfolded as a rectangle like over here. Okay, now I got the area of the strip over here. Now to get the number of people in this strip, what I have to do is I have to multiply the area of this small strip by the number of people we have per square that is given by f of r. So let's multiply this one by f of r. So this gives a number of people in this particular small strip. So as I said earlier, we have infinite number of small strips. So like when the width of the thickness is very small value over here. So now in each small strip, we'll be getting number of people that is given by this expression. So in this way, we'll be having infinite number of strips. From each strip, we'll be getting some number of people. Now we have to add the number of people from all the strips to get the total number of people in the shaded region. So is it possible to add all the number of, the number of people from all the infinite number of strips manually? No, it's not possible. For that, we have to use the technique integration. So in integration, the integration is the process that combine, that is add. So the number of people from all the strips. So like in each strips, the number of people is given by this expression. This function has to be integrated. Now let me write pi r times f of r. We can write this dr at last. Okay, usually, so this dr gives the width of the rectangle, that is the thickness or the small change in the radius from 10 yards. So the starting radius is 10 yards and it goes up to 50 yards. So the upper limit of the integral is 50. So this gives the number of people at the cursor, that is in this shaded region. So in this way, we are taking many strips, infinite number of strips we are taking with a very small thickness over here. So the integration over here adds the number of people in all the strips from the radius 10 yards to 50 yards. And since pi is a constant, it can be moved out of the integral. Then we get pi times 10 to 50 r times f of r times d of dr. So this expression gives the number of people at the concert. We find this integration in answer choice C. The correct answer choice for this question is C.